So for section 2.3, we're going to go to look at a histogram. Basically, we're going to be doing it. A lot of people think of it as a bar graph, but we will be doing bar graphs specifically for categorical data. This is for quantitative data. So we will use a histogram specifically for quantitative data only. So we are going to put bars that are going to count frequency, but the idea is that those bars are put together because we have this quantitative data. So if I scoot this down, basically, if we look at what we did on 2.2, we already know what goes down here. What goes down here are our categories or our groupings that we did in the previous section. So if I look at 2.2, let's see if I have that right here. We did this before, and these were our categories. These were basically our ranges, went from 360 to 369, 370, 379, 380 to 389. There's a couple ways of doing this. Some I like and some I don't as much, but I will have some people that will put like the actual ranges on here. So they'll put 360, let's see, 360 to 369, and the next one would go from 370 to 379, 380 to 389. I see that sometimes, and then what they would do is they put the frequency over here, and so we would basically just put the frequency for each of those groups. I don't really like that as much. We don't see that as much professionally. That to me is kind of a sloppy way of doing it. So what we do, if I want the first bar to be from 360 to 369, what we do is we put the minimum here at the 360. And the next one, we're going to put the next minimum, which is 370. What goes in here is the bar for 360 to 369. What goes in this one would be 370 to 379, and then the next minimum, 380 to 389, 390 to 399, 400 to 409. So each of these includes the lower but not the top. It's not going to include 410 here. This would be from 400 to 409, 410 to 419. So the next one would be 420, 430, and so on. Okay. Another good habit to get into is, because this is 0 and this is 360, so we did not keep that equal spacing. So what they'll do is they will shrink the x-axis, but we shrink the x-axis only. We do not shrink the y-axis. Now, a lot of people will do this on histograms, and we talked about before that creates an illusion, misleading data. It makes it look like 1% is twice as much and things like that. But you can actually shrink the x-axis, because I don't want to go 0, 10, 20, 30, all the way to 360. So what we do is we shrink it. Sometimes they'll put like this little double line. This shows that that's kind of shrunk. The one that I prefer, and I'll accept either of these, is they do like a little lightning bolt, or if you have one of those old like accordion doors, it's kind of like we shrunk the axis and it got pushed together and shrunk into that accordion there. So that's how we would do that. But I will want a symbol on there to shrink the x-axis, but do not shrink the y-axis. What goes on the y-axis, we said, was the frequency. So I have my list of data, and I could do all those over again, but I don't want to. What I'd like to do is just go, look, what was our frequency? From 360 to 369 was 2, this one was 3, this one's 5. So literally, all I do is from 360 to 369, I make a bar that is, where's my pen? Dang it. I make a bar that is, second, driving me crazy here, too high. And the next one, I believe, was 3 high. And so from 370 to 379 was 3, and I believe the next one was 5 high, and I'll double check that. And I'm not like pulling out a ruler here and verifying exact, but the idea is that obviously 5 should be bigger than 3, should be bigger than 2, so try to keep that spacing correct. Don't have 5 be closer to the 6. Those are the kind of things that I will catch. So what did we say? 2, 3, 5, that's 7, 5, 4, 3, 1. 7, 5, 4, 3, 1. So it's, let's see. Oops, come on now. 7, 5. Now this should match the other 5. 4 should be somewhere between the 5 and the 3. 3, and then looks like I needed one more line to 1. So you need to be able to make these by hand. Okay. Yes, we will use technology. Yes, that's kind of what the rest of the lesson goes into. But on the test, what I'm going to do is I'm going to give you a question where I'm going to have you start by finding these categories and counting the frequency. So if you've got the categories and you've got the frequency, then it's not that hard just to make the histogram. If you've already got all that, then it doesn't make sense that you would go to your calculator and then have it make the histogram. You have all the data to make the histogram. Put your categories on the x-axis, put your frequency on the y-axis, and graph that sucker. Okay. Now on the homework, they're going to give you a big old list of data and ask you to do histograms. I would be using my technology with that. But keep in mind, on the quiz, on the upcoming quiz, and on the test, I'm going to expect you to be able to do these out by hand. Okay? All right, so that being said, here let's go ahead and say there's 2, 3. Make sure I did all the right numbers. 2, 3, 5, 7, 5, 4, 3, 1. 2, 3, 5, 7, 5, 4, 3. Looks good to me. All right. So before I get into the calculator, I want to talk about a couple more things. This right here, by the way, is instructions for those of you who are using the TI-84 or 83 or 82. They're all kind of the same operating system. The notes that I got when I got these from another teacher, they had them all outlined for the TI-84, and I thought, you know what, I'm going to leave that in there because I have a lot of students that will bring it. So you can follow these instructions or check the book. Our book has instructions for that. But in the video, I'm going to be demonstrating how to use the TI Inspire just because that's what I'm using in class. Both are just different ways of getting the same tool here, okay? Before we get to that, though, I want to make sure we outline, and we kind of introduced this in the last section, but I want to go a little further. Key characteristics of a normal distribution, okay? So what we're looking at here in this distribution looks pretty normal. Right? The center of the graph, it reaches a peak and kind of hits that point and then it goes back down. So we have kind of this somewhat symmetry. No, it's not perfectly symmetric. How do I know? Well, this has 4 columns to the right of it and has 3 to the left. So it's not perfectly symmetric. But we would call this roughly symmetric. When I talk about characteristics down here, I want to get more into the numeric. So if I had something that was symmetric, then we know the shape is going to be that it reaches a point and then comes back down, and that we have symmetry. But numerically what happens is if I go to the center of that graph, the median, okay, falls right on the center, and the mean, which we use the symbol x bar, also falls right along the center. So the middle number and the average of the numbers both fall right along the center. That happens with the normal distribution. So if I looked at this list of data that we had here, and I found the median and the mean, they're probably not identical, but they'd be close. Why? Because we said this was not necessarily perfectly normal, but we'd say roughly symmetric, roughly normal. Okay? What we can also have is we can have data that is skewed. What skewed data is not normal. It's not very helpful. This right here would be data that is skewed. It trails off, okay? What a lot of people will mix up is that we will have either skewed right or skewed left. And I'll have a lot of people look at it and go, look at all this data to the left. This is skewed to the left. And that's not what we're looking for. We're looking for the outliers, or if you think of this, a lot of times I always thought of this like a whale. Like this is the head, this is the tail. Where's the tail? This would be skewed to the right. Our outliers, our extreme numbers, are out here to the right. Okay? What that does is it has an impact on the median. The median does move a little bit, but it has a larger impact on the mean. So the mean actually gets pulled towards the tail, towards what we would call our outliers. Just like we can have skewed to the right, we can also have skewed to the left. This would look like the previous one, but this time the tail would be to the left. Okay, so this would be skewed left. The median is slightly pulled, but it would be more resistant to those outliers, right? And the mean would get pulled further away. So they wouldn't match each other up, but the mean gets pulled further out by the outliers, by the extreme values. And then last, we will have uniform distributions, and what that looks like is when I basically have a distribution where the data falls pretty normally straight across. This would be like if I was going to roll a die and I had the outcomes, let's say 1 through 6, right? Well, what would I expect if I was rolling a die? Now, it's not going to be perfect, but the idea is that I should have an equal amount of 1s and 2s and 3s and 4s and 5s and 6, so I would end up with a normal distribution. The frequency should be approximately equal. So you end up with this flat line, this uniform distribution. Okay, I think I used the word normal, which wouldn't be right there. It'd be a uniform distribution. All right, and then just like we did at the end of 2.2, we had other graphs. Well, guess what? We can do other graphs with percentages, with, what was it, cumulative. So we had a relative distribution. So we can have a relative frequency, histogram. Well, how would this be different? Here's the good news. The x-axis stays the same. It's going to be our categories. So we're going to shrink it. We're going to start at, I believe it was 360. Double check here. Yep. And go by tens. So 360, 370, 380, 390, 400, 410, 420, 430. I think we went to 440. Try to make sure, and I didn't do perfect at this, so this gives you an idea of how close I'm looking. There should be equal spacing on these steps, which is going to create equally wide bars. I've had some people go, here's my first bar, and here's my second bar, and then my third bar, and I'm like, no. The bars need to be equally spaced, and therefore they will have equal width of the bars. So what's going to go on the y-axis this time? I'll give you a hint. It's not frequency, it's relative frequency. So basically percentage. So we will basically label here the relative frequency. And that can be either the decimal or the percentage. It doesn't really matter. Just make sure you label what it is. If it's a decimal, leave it alone. If it's a percentage, put a percentage. Okay? So let's go ahead and go back here because we already have this data. These were our percentages, right? I'm not going to go by ones when my highest is 16 or 23 and my lowest is 10. And so I need to pick like a spacing that's kind of logical here. I don't want to go. We should just do that. There we go. I don't want to go 1, 2, 3. That's not going to be practical when I'm trying to get something much higher. So we need to get all the way, I think it was to 20-something%. So maybe we go by, I don't know, 5s. 15, 20, 25, 30. See if that works. So let's see if I have that right. So yeah, up to about 20. Yeah, that should be plenty. So 23% looks like the highest one. So if I do 5s. You could have done 2s. That's not super practical. I think within 5s we can approximate it. Now I do have this currently listed as percentages. So I would want to make sure that since this is not 0.05, 0.10, I would just put in here we're dealing with There has to be a quick way to spell. That's fine. I'd be dealing with percentages. Okay. And my first one looks like it was about 6.6%. So here's what I'm going to do. I'm going to put a bar a little bit above 5 and call it good. My next one looks like it's 10%, then about 16%. So 10, that should be nice and clean. That should be right across the 10. The next one was 16.6, so a little bit above the 15. Okay, this was our 16.6%. By the way, we don't label these. I'm just wanting you to see which one I'm dealing with. And the next one was 23, then 16.6. So 23 should be, why is this doing that? 23 should be below the 25. Then the next one is 16.6. Once again, I'm not pulling out a ruler. It should be above the 15, and it should match the other one. Okay? So where are we at? 16.6, 23, 13.3 should be between the 15 and the 10. I think the next one was 10 again, right? So 0.1 or 10? Yeah. 0.1 and then 0.033. So 0.1 should match the other 0.1. And then 0.33 should be smaller than the 5. Okay? This is a relative frequency histogram. We have the x-axis is still the categories. You don't label that. I mean, you could, but and the y-axis is our relative frequency. How did the shape of this change? Well, let's see. Here is this sucker. Here is this one. So people go, well, it's a little shorter. Well, that's my scale. If I'd actually made this go maybe a little taller, my 5, 10, 15, 20, but the overall shape, it is the same shape as the frequency histogram. This is going to be important later on. Just basically, instead of the frequency, we have converted the y-axis to percentages instead of the frequency. But this ends up being the same shape. It looks just like the other one, just now as percentages. So after the relative frequency, we did cumulative frequency. Same x, starting at 360, shrinking it, 370, 380, 390, 400, 410, 420, 430, 440. So then I look at this, the cumulative frequency now, those are not going to go all the way just to 10. We need to basically go higher because this is going to add up to the total, which I believe was, what, 30? So if I do the cumulative frequency, I don't know why all those went off. Let me see if I can move them. Hey, look at that. There's a big old cheater. Move it. I have it. Alright, I gotta stop messing with this. Let's see. I don't know. It's fine. These are our cumulative frequencies. I don't know why they're off on the screen right now. But 2, 5, 10, 17, we need to go as high as 30. So I'm not going by ones this time. What do we want to go by? Well, I'll have some people go, well, let's go by 10. 10, 20, 30. I think we can do a little better than that. So maybe we take those and we cut those in half and we make that 5, 10, 15, 20, 25. So a lot of times I'll do that. I'll make sure I calculate something bigger just to get it to where I want to go, and then I'll split it as we go down. So between 360 and 370, we had a cumulative frequency of, it looks like 2, 5, 10. So 2, 5, 10, think it was 17 next. I'll double check. That looks pretty good. 2, 5, 10, 17. Let's see. 2, 5, 10, 17, 22, 26. Should be there. 26 should be higher than 25. After 26 is 29. And then a little higher, 30. Should match the top. You're like, well, where did the bars go? And this is kind of an interesting thought, right? The first one was, I don't know, can't see that. Was it 2 and then 5? 2 and 5? Well, basically, this was the 2, and the next one was that 2 plus 3 more. That's where we get a cumulative frequency. So it's kind of cool to see that when this was 2 and this one was 3, that gives us a cumulative frequency of 5. We can still actually see the histogram on this. It's basically the increase that we have here are the bars that were on our previous histogram. Because what we're doing with the cumulative frequency is we're saying take the previous one plus the new one, the previous one plus the new one. So each of these things I highlighted are basically these bars right here, just now being added, accumulated up to the total of 30. It's kind of cool. You don't need to worry too much about that. I just thought it was interesting. We only have one more. We've done a frequency. We've done a relative frequency. We've done a cumulative frequency. What would the relative, cumulative frequency histogram look like? I'll give you a hint. If you're really smart about this, you can save yourself a lot of time. Because if I ask you to graph this, and you already have the cumulative frequency, it should look just like, the cumulative frequency. And I am going to take note here because I did do this in my last video. Make sure that we call this, it is called an ogive. Okay, so I can actually kind of cheat if we're savvy about this and say, let's see, watch me mess up. All right, let's see if I can be smarter than technology here. All right, so if I took this and, good enough. Copy. Sure, you can all do this in your notes too. Paste it. Oh my goodness, that looks horrible. And you don't have to redraw it, but the point is what? The relative cumulative frequency will look just like this, but instead of this being a frequency, which I didn't label last time, instead of this being a cumulative frequency, then this ends up being a cumulative percent. And so all of this changes and is now percentages, but the shape actually stays the same. So you don't have to draw it, but I just wanted you to see it. They're basically the same. We're just going to have percentages here, but the shape itself stays the same. So hopefully that helps you quite a bit. I do want to talk a little bit about technology because everything I'm showing you now is going to help you on the quiz and on the test. But I don't want you to have to do all these by hand. That's not realistic. So what we do is we're going to use some technology. Let me find that here. There we go. So I've taken a moment and I've typed in all the numbers. Okay, so if you need to pause the video, you can. But these are all the numbers that we've had before, and we're going to type them in. So 423, 369, 387. There should be 30 numbers in total. Okay, so if I wanted to, let's say I wanted to order this and do this by hand. If I wanted to make this by hand, I am not liking this whole like mark them off and count that, right? So we talked about we could put all these numbers in order. Let's review that. To do that, I need to not be on a number. If I go Menu, Actions, Sort is not highlighted because I'm currently on one number. It's like, how are you going to sort one number? You can either push up to highlight the entire column, or if you're just outside of the column, kind of above it, you can go Menu, Actions, Sort. It highlighted the column. Sort, I could choose a different column if I was like, no, I want a B or C or whatever. But column A, in ascending order. And now I see my lowest number. So this actually makes some things a little easier when I'm making a graph. Because how many numbers did we have from 360 to 369? Now I can see 2 numbers here. How many here? 1, 2, 3 numbers here. So it's a kind of a quick way that you can order them. How many between 380 and 389? Looks like, what is that? 1, 2, 3, 4, 5 numbers? 1, 2, 3, 4, 5. Yeah, so you can do that and kind of get those frequencies a lot faster. So make sure you know how to sort them, okay? So this we've done before, but if I just wanted the calculator to graph this for me, and you need to be careful because if you do this on the test, the calculator will sometimes make some really stupid decisions, okay? But if you're going to do this in your homework, because that's what I really want you to do, I don't want you to have to do all of those by hand. To graph this in the calculator, you have to go to the top and you must give it a name. So this was batteries, so I'm going to call it batteries. If you don't want to type that much, you could just call it AA, or you could just call it A, whatever you want to do, but it must have a name. Okay? Batteries, I'll just call it BAT. Okay? So once I've named it, I go to the home screen, literally a picture of a home. I choose the 5th option over, which is data and statistics, and notice it's a picture of a histogram. That's what we're wanting. Okay? I can use this. I can hit I think I can tab to click around if you wanted to, but what's easier is use this keypad to move the pointer, go to the bottom, and you can click it and add what is our X variable? Well, the batteries. This would be a dot plot. This is not what I really wanted, but it's a dot plot. If I go to Menu, Plot Type, where do you see that I could make this a histogram? Now notice, it did not do the same exact graph that we wanted. It didn't actually make it exactly like I wanted. The first one goes from 362.5 to 367.5. So this is not how I want you to do it on the test or the quiz. But this is enough to, I would do this on the homework and see if you can answer the questions that way. Definitely want to use technology, but this is not going to be the way you should do it on the quiz or the test. If you have already done a frequency distribution, then it's just as easy as taking that and putting it on the paper. Okay? So what do we do then if I want it to look like the one from the done by hand? I can actually change the X scale. So I don't do this all the time, so I'll have to think about it. Plot properties, I think. Looks like histogram properties, and I can change. I can change the percentages, but I'm going to go ahead and change the binary settings, and I'm going to basically, you have to change the width of each of these bars. Okay, so we didn't set it 5 wide. Remember, our numbers started at 360 to 369. That is 10 numbers, not 9, right? So I'm going to start at 10 numbers, and we didn't start at friggin' 357.5. It's utter nonsense. We started at 360. So basically the calculator just automatically kind of throws this up here just to make a quick sketch to give you lots of bars so you can see the overall shape. But this is the way we did it, starting at 360 going by tens. And that, right, the scale is now off for the Y. Freaking A. So if I go Menu, let's see, window zoom, I would probably need to change the window settings. The Y shouldn't go to 4 because our max was way higher than that. I'll make it something like, I don't know, how about 8? I think that should be good. Now this looks like this. it looks exactly the same. Still don't like the way the x-axis, so I can kind of shrink that over so I can get that all over. What's the point? You don't want to have to keep doing this in the calculator. This is what I want. And your calculator won't automatically do this. Yes, I can make my calculator do it, but for the amount of work that you're going to do, you need to be able to just do it by hand for the test and for the quiz. On the homework, feel free to put them in the calculator and use that to kind of eyeball it. But there you go. One kind of interesting thing, here's a frequency. What happens if I do change this to, I saw it in here, what if I change it to a %? Did the actual graph change? Well, it looks a little different, but what? All it did was zoom it in. The shape of the graph is identical. It's just from this is frequency. This has 2, 3, 5, right? 2 percentages, 6.6, 10%, 16.7. The frequency histogram looks identical to the relative frequency histogram. Okay, so I did show you the calculator, but I do recommend not being over dependent on that. Please let me know if you have any questions on this, and keep up the hard work.